All right, guys, so we're officially moving on to Unit 2, which is our 2D kinematics. So to do things in 2 dimensions, we have to go back through some review. We're going to start with drawing vectors. Remember, our vectors are going to give us a magnitude and a direction. So your velocity, your acceleration, your displacement. So far, those are all the vectors that we have. They're telling us how far, how fast, and then which direction we're going. So we need to kind of review our directions so that we know what we're talking about when we get into the more complicated stuff. So we've got a compass rose. Look at that. You're going to be filling in the main coordinates on your notes. So we've got northeast, south, and west. And you'll notice that the degrees are labeled differently than you would in like a math class. Normally on a math class, you would see essentially what's labeled as the direction east would be at 0 degrees, and you would go around counterclockwise from there. But what we're actually going to do is start north, and you're going to go clockwise around. And that's just because physics is using math in the real world. And in the real world, we think of north as like straight ahead. Then you have your sub-directions. So you have northeast, southeast, southwest, northwest, and they are at 45-degree increments between those main 4 directions, your cardinal directions, if you will. So when we look at this, this slide is a little off. It's not an angle measured counterclockwise from north. We're measuring an angle clockwise from north. So it's saying that we're either at 113 degrees. So you start at north, and I'm trying to think which way it's going that matches the slide. You're going to go 113 degrees, or if it says east 23 degrees south, that means that same thing as you go to east, and then you're going to add 23 degrees south to your eastward direction. So it gets a little tricky in how we're saying it, but you're going to need to know how to interpret all 3 of those examples. So you're going to go to, like for that second where it says east 23 degrees south, you go to east, and then you go 23 degrees south. And then 23 degrees south of east, you're going to start at east and go to that 23 degrees south. The other example is 285 degrees. So we have to go from north, and we go all the way around. And we can also say that that is west 15 degrees north, which means that you're going to go to west and then go towards the northern direction 15 degrees. So we need to remember that vectors have both a magnitude and a direction. And when we draw a vector, we're typically going to start by drawing a guide so that we know which direction we are starting in. And once we have that like main compass rose, so your north, south, east, and west, then we can measure angles. So from the center of a compass, you're going to draw the vector, which is just going to be a quick line that ends with an arrowhead because that line would continue on going. Our lines don't end. They're going to keep going. And we don't want technically the arrowhead to add additional length to the vector. We're not going to go so far as to draw things to scale as of right now. But if you're trying to draw something to scale, you need the very tip of that arrowhead to match up with the very tip of the line. So if you have a certain, like you're trying to go 2.3 centimeters on your line, you don't want to put the arrowhead at the above that. You want to put it starting at the very end of that 2.3 centimeters. So for these examples, we're going to do examples of these vectors. And this is when you would need a ruler for your assignment. Please make sure that you have a ruler. If you need to print one off from the internet or use, whatever you need to use. Rulers. So we're going to draw these examples. So 2.5 centimeters north. So I'm going to go north 2.5 centimeters. And if I go to the very tip of that arrowhead, then that is going to be exactly 2.5 centimeters from my center. 1.9 centimeters southeast. So I'm going to go to the south and then over in the east direction and hit that 45-degree angle there. And it would be 1.9 centimeters long. So the difference in length is showing us our different magnitudes or how strong whatever we're measuring is going. And then we have 15 centimeters north, 20 degrees west. So this is where we're going to go to the west and then go up towards north about 20 degrees. And you're going to draw your line 1.5 centimeters out. So then I want you to draw all these following vectors from a common starting point, which is going to be the center of our compass rose on your notes, and label them with your appropriate variables that they're listed in your notes. You can use different colors, but you don't want to draw your vector lines too thick. You want to keep them pretty thin so that it's showing a pretty pure direction. And make sure you're paying careful attention to the magnitude or how long the line is. So this is in your note pages, and I want you to go ahead and pause and try to get those written down, measuring out the exact length, and then do your best with your degrees. I know we don't all have a protractor at home. If you do, go for it. Otherwise, just do the best you can. And I'm going to go ahead and skip ahead to the answers. So you've got A, B, C, D, E, F, G, H, I, J, K. Oh, no K. Anyway, so this is essentially what the end result should look like. It should be all different lengths, and then you label them with their vector hats and in the right direction that they should be going. So the starting point of a vector is called the tail, and then you have the arrow, which is the point that keeps telling you which direction you're going. And to add two vectors, so to add vector A with vector B, you're going to just go and add, you're going to draw out A first, and then where that arrowhead ends, you're going to draw vector B attached to it. So you can see it right here, vector A, and then where it ends at the point, you start drawing vector B. And then the connecting line would be your resultant vector A plus B, and this is called the head to tail method. So the resultant vector is going to start where your A vector started and end where your B vector ended. And that's going to tell you if you were to do both of those things, both of those displacements, have that velocity, those accelerations, then that magnitude, so the length of that vector and the direction it's going, would be the result if you kind of went the way the crow flies. So you can add as many vectors as you need to together to get the result. So it's like if you're driving down in downtown Ava and you're taking all those turns and you're like, I wonder how far it really would be if I could just cut through everything. That's what the resultant vector is going to show us. So as long as you go and draw one full vector and then at the end of that start drawing the second one, then you're set and you can get the resultant at the very end. So now we're going to go through the practice problems. If you have any questions, shoot me a message. Maybe. Boop.